Hey everybody, welcome to Bill Sky, the Fortran guy, and this is our second video in my Fortran series that I just began a week or so ago. And what we're going to do today is we're going to talk about variables in a Fortran program. Before that, we're going to talk about the program structure and what your source code needs to look like, but then we're going to talk about variables and how to create them. So we're going to try and mix those two around. So I think we should just get going. Okay, so I have Windows up and running here now. I could be using the Visual Studio 2022 with the Intel compiler, but I've decided to use the Eclipse with the G Fortran. It doesn't matter, they work exactly the same way. Fortran's easier to get a hold of, it's smaller, it's quicker, or I should say Eclipse is. So I'm going to create a new project. And I'm going to go down here and just select a Fortran project. Now, if I think on this Windows, I actually don't have the Intel Fortran installed on this particular Windows machine. So, but I do have the G Fortran that was installed using MSys2. And if you don't know what I'm talking about, you should see the previous video to this one because I show you how to do that. So I'm going to go ahead and just use the GNU Fortran, and we're going to call this Fortran variables. That's what we're going to call this project. And I'm just going to turn off release and leave debug on because I don't need to have two versions being built for just this class. Okay, so once I create the project, there's really nothing in it. I have to right click on the project and say new Fortran source file. Now, it's actually very important what extension you put on a Fortran source file. If you end it with .f90, that's Foxtrot 90, F90, the letter F90, then you're going to get a newer version of Fortran, or you're going to get a newer capabilities of the Fortran compiler. If you end it with .4, F-O-R, you're going to get the old version, the Fortran 77, which by the way is still in use, but it has a lot of limitations which we're going to talk about. So I'm going to call this one main.f90 and then just click finish. So here's our program. Now it kind of looks kind of weird because we have some spaces out here. Well, let's talk about what those spaces are. This is what we call a fixed form Fortran program. And what that means, it's a lot like COBOL. What that means is that you've got to start your code at a specific position in each line of code. And this is old from back when we only had punch cards that had 80 characters on it. You had to have some way of saying, okay, you can only do it within these characters on the card. And that still is alive and well, believe it or not, in a lot of Fortran programs. I believe this one is going to be what we call freeform, which means you can put the code anywhere you want. But let's talk about it real quick. So the first 5 characters of a Fortran program is like the statement label. It's like a label that you could do a go-to with, or it's it identifies that line of code. And most of those are blank. The 6th column, which is right there, that's a continuation column. That's a continuation indicator. It means that if you've put in so much line of code on one line that you need more than 80 characters, that by putting a dash there, I'll give you an example. By putting a dash there means that it will continue on that line. So if program main, if that line was really, really long and I needed to continue it, I would put a dash on column 6. And that is one nice thing about the Eclipse compile. Well, I have to say the Visual Studio is the same way, is that based on the extension of your file name, it will actually set this up for you. Okay, now columns 70 through 72, so there's, or 7, I'm sorry, 7 through 72. So here's column 7. 7 through 72 is actually the program code for each line, and then 73 through 80 are line numbers. And why do they have line numbers? Well, I remember when I was first learning to program, when I actually started learning to program in a higher level language other than machine code or assembly language, you would walk around campus with these huge boxes of punched cards, and if one of the big burly football players tripped you because you were a geek, then your cards would go flying all over the place and you wouldn't know how to put them in order. Well, a sequence number at the end of each line of code says, is this the first card, the second card, the third card, the fourth card? And we don't use them so much today because we really don't need them because everything is online like this, or actually in the computer. And by the way, that actually never happened. A burly football player tripped me. It was a hockey player. All right, so let's talk about this code. So the first line of code is the program name. In this case, it's called program main. Now I could change that to anything. I could say Fortran var, and then the end program must have the exact same name. It just specifies the beginning and the end of your program. Now this is a lot like a function, right? A function in some languages like C and C++ and Java, Python, they have to have a name. Well, there's no difference here. It's just, it has a word program and it has the word end program. And then within there, within that scope, that scope of the program Fortran var, that's where you would put your code. Now, one thing right here, we're going to start talking about variables right away. One thing right here is I believe the Intel as well as the G Fortran open source, it puts this thing called implicit none. And let's talk about what that means. Implicit none, well, how do I want to say this? Let's talk about that in a second. Let's start defining some data. So I want to create an integer. So to create an integer, I'm just going to say integer int1. That's integer int1. So that's an integer. Okay? I'm going to create a real floating point, and I'm going to call this float1. I could create a character, middle initial. I can create a logical, true, false. So the data types that we're seeing so far is integer, real, character, and logical. There's also another one. There's one called complex. And what a complex number is, it's a pair made up of a real and an imaginary part of the number. And in science, you use that quite a bit. You use something like that. In mathematics, you use something like that quite a bit. We're not going to use it. We're not going to talk about it in this. We might talk about it in this course, but later on. But these are the basic data types that you would have in a Fortran program. So let's go ahead and build that and make sure everything is copacetic. Oh, it looks like I don't have the Fortran. Yeah, it's interesting. I don't actually have the Fortran compiler set up on this correctly. That's interesting. Well, let me go ahead and fix that. And you might say it can't find the word make. It can't find the program make. Now, the reason for that is because Eclipse generates its own make file. And if you don't know what a make file is, oh my God, you got to learn that. I'm going to have a series of videos on it. But a make file specifies the way that a program should be compiled and built and linked. So what I'm going to do is I'm going to go into the properties of this PC. I'm going to go into advanced system settings, and I'm going to go into environment variables, and I'm going to double click on path. Now, one thing I forgot to do is you can see I did the compilers for the MSys64, but I didn't add a path to the utilities within MSys64. So I'm going to go into there, and I'm going to go into MSys64, and under user, is there a bin directory? A bin directory or bin folder is where all the binary files are. So I'm going to click OK, OK, and OK. And I'm going to close this and I'm going to restart Eclipse. So a bin directory in Linux, in Unix, as well as some versions of Windows as well, bin means that's where our binary files are, that's where our executable files are. Not so much Windows, but in Linux and development environments like that. So let's go ahead and restart Eclipse. Now you would have this problem on Visual Studio or whatever. You've got to make sure that the operating system's path specifies all the places where your code is located. So let's go ahead and restart Eclipse and go ahead and start building our code. All right, so there's our code. Now let's see if it'll build this time. And it looks like it is. It's invoking the GNU Fortran. And let's look at some of our errors or messages. It says unused. These are just unused variables. Big deal. It's just a warning that it's unused. I haven't done anything with it yet. All right, great. Now let's go ahead and do something with our variables. So I'm going to go ahead and put into int1 0. I'm going to go and put into float1 that number. I'm going to go ahead and put in the middle initial that number. And I'm going to go into true, false, and put in that value. Let's see if this compiles now without any warnings. Yep, I think we have an error here. It doesn't know what true is, so we have to actually get the correct Boolean. So to fix this, all you have to do is put a period in front of the T and at the end of the E. And it's kind of interesting. It's kind of like a constant. And there you go. So now you actually have some values. Now let's go ahead and run this. It's not going to do much. Now when you click run on this, you want to make sure you specify that it's a local Fortran application and click OK. And it really doesn't do anything. It does show right here that it terminated with an exit value of 0, which means the program ran okay. Okay, now something I mentioned earlier that I said I would talk about later, and I think this is the appropriate time, is this implicit none. What implicit none means is that get rid of this idea of the first character of a variable name indicating the type of data that it is. Whoa, what's the teacher talking about? Well, I'm going to go ahead and put a comment here. And comments begin with an exclamation mark. So in early versions of Fortran and even current versions of Fortran, any variable that begins with the letter I, J, K, L, M, or N were by default integers. Anything else is a float. So if we get rid of this implicit none, it's going to go back to these rules, that any variable with I, J, K, L, M, or N are integers, anything else is a float. Now, why? Why did they do that? Well, by turning off implicit none, what you can do is you can define variables anywhere in your program. In other words, I could create a variable here called I, my age, equals, do I want to tell you how old I am? Okay, I'm 39. Okay, I, my age, this is an integer because it begins with the letter I, and I can define it anywhere I want. Let me go ahead and save and build this. And it looks fine. Everything looks okay. There's, oh, wait a minute, nope, got to save it first. Everything looks fine. There's no problem. However, if I turn off, or if I turn on implicit none, and I try to build it, we're going to have an error. And the reason that we have an error is because this variable was defined within the logic of the code. Now, there's not a lot of logic in this program. All I'm doing is assigning values to variables, but it is sitting after actually executable statements. So I would have to move this up here. Also, with implicit none turned on, this can be anything. This could be a floating point number. Let's actually, I don't think that's going to build, because when we say implicit none, it has no type. We didn't specify a type. So again, if you turn off implicit none, that means you can define variables anywhere in your program you want, kind of like C and C++. Not a good idea, but kind of like that. And you don't have to specify the data type because you basically only have integers and floats. So if you turn on implicit none, you would have to specify that this is an integer called my age and it's equal to the value 39. Let's see if that'll build. And it does. It gave me a warning. It says, you declared, but you never used it. So that's what implicit none is all about. Now, are you ever, as a modern Fortran programmer, are you ever going to see this? Yep, you certainly will, because you're going to have to deal with old Fortran programs. So just keep that in mind. Okay, so that's done with that implicit. Now let me make this window a little bit bigger because we're getting into some coding here. Okay, so because I have implicit none turned on, I actually have to define all my variables up on top, which is perfectly fine. So let's say I would like to print some of these. So I'm just going to use this statement right here. I'm going to use the print statement. And we'll talk about the format of the print statement. So I'm going to say print asterisk float 1. And we'll talk about what that asterisk means when we get into the depths of the print statement. I want to say print asterisk middle initial. Let's go ahead and save and build that. And then let's run it. And there's our 1, 2, 3. Oh, that's interesting. 123.45 is actually stored in the CPU as 123.449997. Oh my goodness. Why is it not more accurate? Well, that's because you can't store floating point numbers 100%, not all. I shouldn't say it that way. There are some numbers that you can't store perfectly accurately in the floating point unit of the CPU. So Fortran doesn't fix that for you. You would have to fix that yourself. And if you want more information about this, I actually have an assembler language video that talks about the accuracy of floating point numbers in the floating point unit, and it tells you all about that. Okay. How big are each one of these? Let's do this. Let's say I'm going to print huge float 1. Now the function huge is a built-in function in Fortran that tells you what is the largest value that can, or what is the largest value that can be stored in that floating point number. It doesn't really tell you the size, but it tells you the largest number. And so the largest number that you can store in a floating point in a real is, boy, 3.402 times 10 to the 38th power. That's a huge number. Okay, so we're going to continue here. Let's go ahead and create another integer. And what we're going to do is we're going to create an integer. Now, if you remember correctly, if you've got any experience coding in C or C++, there's different sized integers. There's a short, there's an int, there's a long, there's a long. Each integer has a size based on the number of bytes that it takes to store it in memory. So you can actually do the same thing in Fortran. I could say integer. Now in parentheses, I'm going to say kind equals to word int, and that is going to take 2 bytes. I'm going to say integer kind equals 4 word int. I'm going to say integer kind equals 8 word int. And then what I'm going to do down here, I'm going to say print I'm going to print the maximum value that you can have in any one of those. Go ahead and build that, and then let's run it. Okay, so you can see right here that a 2-byte integer can have the maximum value of 32,767. A 4-byte integer can have 2.1 billion, and these are signed integers. And then the quad word integer, that can be the maximum value. So it's much like C and C++, these are signed. So what about unsigned integers? Well, unsigned integers are not a standard within Fortran. I believe that Intel has the unsigned data type in its Fortran compiler. So instead of typing integer, you would type something like this. And you would get a 2-byte unsigned integer out of that called word int. Now, but that hasn't become a standard. That is not a standard from whatever the organization is that keeps the standards for these languages. That is not a standard. It's something extra that Intel has added. So I've had people ask me, well, if it's not a standard, and let's say your Fortran program is going to call a C program or a C++ program or function, and that function requires an unsigned, well, you just have to make sure that the number of bytes that you're sending to that function is the same as what it's expecting, and it'll always be signed in Fortran. So you have to make sure that you're not sending a negative number if your C program or C function or C++ function is expecting a positive number. So your Fortran program has to think about that a little bit. Okay, so we've talked about different kinds of integers or different sized integers, but you can do the same thing with floats. So I'm going to create a real, or I should say real. I'm going to create a real where I say kind equals 4. And this is basically a float. Now, if you know C or C++, you have a data type of float. Now, if you've never heard of that in those languages, it's probably because you've been using doubles a lot. But a float is a single precision floating point number. I can also say real kind equals 8. Now, this is probably what you're used to. This is like a double, and it's a double precision floating point number. You can also say real kind equals 16, and that's going to be, wow, that's going to be a long double. And we could go ahead and print those. Print those, the largest number that we can do in each one of those. Let's just do that for some fun. Let's see how big those numbers can get. Let's go ahead and save and build this. And let's run it. Them are some big, big numbers. Fortran is meant to be a scientific programming tool. So a floating point, a simple single precision, can be 3.4 times 10 to the 38th. Double precision, 1.79 times 10 to the 308th. Or 1.189 times 10 to the 4932. Huge, huge numbers. Those are really large numbers. So you can not only can you create a kind with integers, but you can also create kind with reals. You can also create kinds with complex numbers, which we're not going to go over today. We may in a future video. But this gives you the ability to be more like C and C++, but also specify the accuracy that you want your floating point numbers to have. Okay, so those are reals and those are floats. Now, what about a string? How would I create a string in Fortran? Again, I'm going to put it up at the top. So let's say I want to create a string of size 80. So I'm going to say character, and I'm going to say len equals 80. Notice I put that parentheses. I'm going to call that full line. Let's make another one. Full name. And then let's come down here and let's put some data into those. Oh. So I'm going to say full line equals, this is a full of data. Let's see. And let's say full name. And just assign some data to those variables. Oh, I forgot to save it. I had that unsigned. Oh, I still have that unsigned. Did I get rid of that? Yep, I got rid of that. Okay, there you go. So now let's go ahead and print full name. So I'm going to say print full line, full name. Go ahead and print those. And there you go. So you can see how you can print them. So what have we done in this video? What we've done is we've created a Fortran program. We're using G-Fortran, but this works exactly the same on the Intel's Fortran compiler. We've talked about variable names. If you don't have implicit none turned on, that means that any variable name that begins with I, J, K, L, M, N are integers. Any other name is considered a floating point. If you have implicit turned on, then you have to specify all of your variable names at the top of the program, which actually is very, very good practice. Why? Because the assembler does that anyway. So if you have a C program or a C++ program, it moves all that up into the data section of the assembler code anyway. So it's just a good idea to do it that way. We've talked about what comments are. Comments are lines that begin with an exclamation mark. We've talked about different sizes of integers. We've talked about how to assign strings, how to create the string variable, and then how to assign a string to that variable. We've even talked about how to print data a bit. And we're going to talk about this asterisk comma up here. And what that means, it means I need to format the data a certain way. And when you just say asterisk, it means just print it. Just print the data. We've talked about how to assign values to variables, and once again, we've talked about printing those variables and how to end the program. So there you go. So our first Fortran program, creating some variables. It's not too difficult. It's not too complicated. We're going to do more about this. We're going to talk about printing more. We're going to talk about doing arithmetic and some heavy-duty math, because that's what Fortran is all about. Hope to see you in our next video.